team, welcome. Thanks for taking time out of your day to come and join in and join the community. This is a talk on Kubernetes for the next decade. After I submitted it, I realized it's kind of ambitious for like 15 minutes to talk about the next 10 years. So I don't know, give me a little bit of slack. Before I get into that, I just wanted to echo some of BMK's words from before. Here in the bottom of the South Pacific, we are incredibly fortunate to have BMK and Chris putting on this event for us. So please, keep coming along and joining in with the community. That's a map of all the other events that are happening across the globe. So very quickly, who am I? My name is James Blair. I'm a specialist architect at Red Hat, based here in Wellington. Love open source. I'm one of the currently 5 maintainers globally for etcd, the data store used by Kubernetes. I'm also the co-chair for the etcd Kubernetes special interest group. If you, just referring to the card on the left-hand side there, this is something that was announced at KubeCon in Paris just a couple of months ago. If you contribute to projects and you want to tally up your internet points, you can go to that URL, put in your GitHub username, and you'll get the fancy card you can show your boss. So go ahead and do that. Team, it's 10 years. So are we there yet? Are we done? Can we all go home? Is a job done on Kubernetes? I hear it coming up quite a bit, that kind of question of like, when do you say the software is done? Obviously, I am extremely biased in this, and I'm going to make a bit of a case that we've still got a bit of work to do. So some quick predictions. Got 5 for you. Ironically, contrary to what many of you thought, the first one isn't about AI. I suspect some of us, maybe some of us in this room, will be spending the next 2 to 5 dealing with virtual machines and bringing those into Kubernetes. Alongside that, bare metal will become the norm, not the exception. I suspect a majority of our clusters, this is where the AI piece comes in, of course it's in there somewhere, a majority of our clusters will, next 10 years, have more than just CPU for compute acceleration. But I do think there will be alternative options there in terms of the monopoly of, basically you've got to talk to NVIDIA at the moment, right? That's going to change. And I suspect, this may be a little bit wild, but orgs that are running Kubernetes, I think with the improvements to tooling and ecosystem and layers of abstraction, I think everyone will be doing their own CRDs with their own controller loops. So, predictions out of the way. Let's talk about 2.x. We're like 30, almost 31 minor releases into Kubernetes 1.x now, right? We're all like so busy just doing the dance of being a platform engineer or being a developer, interacting with our clusters, and we just get so used to how things work. I'm not sure we kind of get the opportunity to be up on the dance floor, up on the balcony, asking that question of if what we have right now is actually what we're going to need for the next decade. So, unfortunately, again, 15-minute talk. I had to pick something, and I've got one specific example I want to have a tinker with in this talk. And it is, what happens to our pods when the node they're on fails? Someone take a stab at it. I mean, it's not a trick question. What happens at the moment, team? If you've got a pod on a node dies.
Like automatically.
Yeah, thanks, Ben.
It's not a deployment, you just said pod, so it's gone.
Yeah, it depends on if it's orchestrated by a high-level resource like a daemon set or a deployment or a stateful set, 100%. But magically, we would hope we've got something there, and that pod would be rescheduled onto another node, hopefully. But our application, it's going to restart. We can kind of go back and confirm that, but we've talked about that, so that's all good. What's the issue with that? I think, to put it in a picture says 1,000 words, put it in meme format, I think it's something like this. But what is it really? It's basically, we're at the curly end of our migrations to Kubernetes now. Like we've got all the sort of weird and wonderful stuff that we've left alone and it's still sitting on VMs. And we've kind of got that hairy stuff to deal with now. We don't want to refactor all of those. Some of them we're just not going to invest in. They're not going to be transformed into a magical, 50 microservice cloud native thing. It's going to stay that weird and wonderful thing that it is at the moment. The challenge of dealing with host failure, that's nothing new. We've been dealing with that forever. Interestingly, we like to rib on them, but our hypervisors had a pretty awesome solution to this. If we think of like KVM's got live migration, it's all, table stakes really. And I think what it boils down to is, Kubernetes was designed originally for mainly stateless workloads, right? And I think we're starting to feel a little bit the impact of some of those design choices now as we get to the tail end of some of these migrations. So what can we do? Obviously, we can invest in the application and we can try and do things there. Yes, obviously. But like I was saying before, we probably in a lot of cases don't want to do that. We could just say, yeah, live migration works great. I'm just going to use kubevert. I'm going to wrap it in a VM and just rely on live migration. It's a thing. You can do it. It works. It's great. But it kind of feels a little bit forced, like we're losing some of the benefits of just having an ordinary container. So how about this weird and maybe wonderful idea, maybe wacky idea, of extending Kubernetes to support live migration for an ordinary container? So no longer having that kind of application restart when our pod is killed on one node and restarted on another. So that's what I've been tinkering with, and that's what I want to have a bit of a chat about. If we're talking about live migrating containers, we are talking about processes. A container is not a great description, but it's just a fancy Linux process, right? So can we freeze and restore a Linux process? Turns out yes. There is this really cool project called Cryu, Checkpoint and Restore in user space, which fundamentally lets you do that. So you can take a running process on Linux, dump it to disk as a bunch of files, memory, file descriptors, open sockets, TCP connections, everything, and then restore it from the point it was frozen at. So let's have a look at that. Let's take it for a spin. Now I don't have the lapel mic, so I'm going to have to like dump this thing down and then pick it back up again. So apologies for any distortion here. Yep, all good. So what I'll do is this thing. Does anyone, I don't even know, I might make it a little bit bigger. Does anyone know what this is? Someone's got to recognize this. I know you know it.
It's Star Wars Episode 4.
It is Star Wars Episode 4. Okay, so this is a site you can telnet to, and it will play Star Wars Episode 4 in ASCII form in your terminal. So provided I have some internet, yes, awesome, it's working. So very shortly, the movie kind of kicks off, and I just thought this was a fun example. It's kind of this really, it's been around for like, I don't know, decade now? I remember looking at this when I was a kid. So it's something that involves active network traffic. It's kind of an interesting process to maybe test this with, right? So yeah, here we go. Star Wars starts doing Star Wars things. Yeah, you get the idea. I'm just going to zoom out of that. I have to make the terminal bigger. Okay, cool. The movie's playing. It looks a little bit balked because I've been like resizing the terminal, but it's playing. So what we'll do is we'll dump this to disk and try and restore it. Oh, there we go. So if you remember episode 4, it's episode 4.
Any sound effects, James?
Sadly, no. You feel free to jump in, Ben, and supply the audio. All right, so what we can do is I'll just quickly do a PS to check the process ID for telnet. Here we go. So it's this top one here. 20303. And what I'm going to do is I'm going to dump that process to disk. There we go, put in our process ID as the target. I'm using the flag for TCP established because I know this app has like network things going on, right? And I'm using the directory of checkpoint. So let's run that. And credentials. Now notice that our movie has stopped playing on that frame, on that screen. So let's go back and restore using that same directory. It'll take a moment, and our movie keeps playing. Obviously, if I had killed this and restarted it manually, we'd be back to the start of the movie. So that is basically freezing a Linux process, checkpointing it to disk and restoring it. Pretty cool stuff, including like network in progress, TCP connections. All right, so that's the building block that we have to work with currently. What does that mean for containers? How does this work in a Kubernetes context? So if we've got a node, we've kind of got layers of things happening on that node that all sort of need to be working in symphony here for this to play nice. Long story short, we're not quite there yet. We've got more work to do. Run C, like from a low-level runtime, is all good. It supports checkpoint and restore. Awesome. Same with cryo, which was first, for both checkpoint and restore, and containerd merged like 2 weeks before KubeCon Paris, so just like 3 months ago. Kubelet has alpha support for taking checkpoints, nothing for restore yet. It's kind of the use case I've been going after is security forensics. So if you have a container that gets popped, you can use this alpha API from Kubelet to basically dump it to disk and go and take it to a secure lab and investigate what's going on. And API server has nothing yet. There's an OpenKEP Kubernetes enhancement that's in progress, and there's a proposal for a kubectl checkpoint command. So things are kind of happening. But it's not there yet. Can we just hack around it anyway? What do you reckon, team? Yes, of course we can. There is a project called Crick, which is a wrapper for CryU targeting Kubernetes, which allows us to do this currently in a Kubernetes cluster. So let's have a look at how that looks. Hopefully it goes better than the Baboons demo. So I've got a kind cluster running. It's nothing simple. It's just my just my laptop. Nothing serious. And we are just going to apply this little example. It's just a config map and a stateful set. Pretty ordinary. There's one pod. There it is. Simple loop. If we look at the logs for it, all it is, team, is just a bash counter. Every 1 second it increments. It's very boring. I'm happy to show you the YAML, but it's just a bash counter. There it is. Doesn't get dumped to disk. It's just in memory. Increments every 1 second. No surprises. You can see it under the args there, bash-c4, blah, 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 blah. So let's go and basically kill this running container and see what happens in our cluster with the pod that replaces it, because we've got a stateful set backing this, right? And we should see it resuming from the same place it left off. So what we'll do is just delete the pod. Dead simple. So it's gone. We know now, because we've got that stateful set, a new pod has magically replaced it. So let's check the logs for that. We started at 75. If I go back to the other terminal, we finished at 74. From our, sorry, I should be using this. From our workload perspective, we have just moved node transparently, seamlessly, without restarting a workload. Pretty cool stuff. Pretty hacky at the moment, but think about this as something that, in a couple of years' time, could be a new eviction class could be a new method that we use for migrating workloads between nodes. So let's just finish off. Thankfully it went better than that one. Last words, team. So we need to revisit some of these underlying assumptions that we've just been building muscle memory to and getting used to for 10 years now. Kubernetes isn't done. We still have these hard problems to solve. But the awesome thing is we've got this amazing community that will solve them, and we would love all the help from folks on that. And if you're interested in the specific example of like an assumption that we can challenge with Cryu and Crick, for example, there is a talk there from KubeCon in Paris, which goes into much more detail on both of them and how some of the Linux black magic works under the hood. So that is me. Just very quickly, from the Red Hat team, we have some swag bundles. If you are the first 10 people that come and talk to me about doing that QR code, I will give you some swag. So I'm going to leave that for a minute. It's just over in the box over there. So grab your phone, do the thing, and you can get a bundle of Red Hat swag. But that's my talk. Thanks very much.